This video is for my Calculus 1 class. This is our log practice lab. We will be working on this in class, and I will give it to you for homework as well, but I wanted to practice it with you so that you can follow along with my steps, especially if you have a question along something. So the very first one we have there is 2 to the x equals 12. So what I told everyone when you do logs for me, basically logs are an inverse of exponential functions. And what I want you to do is to be able to solve them using inverses or exponential functions. And so we're going to use logs, all right? In this course, I only use natural logs. So the first thing I always tell everybody is to do normal math first. Okay. And what I mean by that is to actually add, multiply, divide, everything that you've done normally. And then when you can't, you're going to natural log both sides. When you natural log both sides of your equation, you're going to be able to use the log rules. And then you're going to use your logarithm rules to solve. Okay, so let's do the first one. All right, so the first one is 2 to the x equals 12. There's really no normal math to do, so the first thing I'm going to do is natural log both sides. So I'm going to natural log this side and this side. When I do that, one of the log rules is I can bring the exponent down. So I'm going to do x natural log of 2 equals a natural log of 12. Okay, after I do that, then I'm looking to solve for x because that was the whole purpose of doing this. And this natural log of 2, it is like the constant, and behind the x, you're used to something like, we'll say 2x. This is like x times 2. So this is a constant, a number, so you can divide that both sides by the natural log of 2. When I do, I have x equals a natural log of 12 over the natural log of 2. Okay, and when you put this in your calculator, I want you to go at least 4 decimal places. So x is going to equal 3.5850. Okay, let's try the next one. I'm going to use different colors here. So you can stop this and do a few and then check them. This one is 19 to the x equals 3. I look at it, is there any normal math to do? And there isn't, so I'm going to natural log both sides. And this will be x natural log of 19 equals a natural log of 3. These are hooked by multiplication, so x equals the natural log of 3 over the natural log of 19. And when I put that in my calculator, I get 0.3731. And you can check these by plugging it back in. It won't give you exact sometimes, but 3731. It won't give you exact, but you could plug in 19 to the 0.3731, or if your answer is still left in your calculator, and you should get the answer of 3. Okay. Now we're going to we always start easy and get harder. So this one right here, I have 27 equals 2 times 5 to the x. So I look at it and say, wait a minute, I could natural log both sides and use my log rules. However, I see there's a 2 times 5 to the x. So I'm going to use some normal math and divide both sides by 2. So now I have 27 over 2 equals 5 to the x. Now there's really no other normal math to do, so I'm going to natural log both sides. And when I do, I have the natural log of 27 over 2 equals the natural log of 5 to the x. And this is a number here. This, I can bring the x down front, so I can say the natural log of 27 over 2 equals x natural log of 5. Divide both sides by the natural log of 5. I have x equals the natural log of 27 over 2 over the natural log of 5. And you really should practice putting this in your calculator, just because making sure that you can put it in correctly. And when I do that, I get 1.6171. Okay? So these are going to get a little bit more difficult, and I'm going to throw base E in there as well. So this one right here, I look at it, I have 2 times 3 to the x equals 7 times 8 to the x. I could start natural logging it right off the bat and pulling it apart with addition, but I want to do some normal math first. So there's a couple ways you could do this. You could divide both sides by 2, or divide both sides by 7. I'm going to divide both sides by 2, so when I do that, I get 3 to the x equals 7 over 2 times 8 to the x. So a lot of people say, well, why isn't the 8 to the x divided by 2 as well? But as long as I divide that side by 2, you're fine doing it that way. Now, people are like, okay, I'm going to start natural logging, but remember what I told you about exponents. You can combine them if your bases are the same or your exponents are the same. These have the same exponents. So I'm going to divide both sides by 8 to the x. So this is what I have. Okay, so I'm doing just regular math here, getting it simplified. And if I have a fraction and they're both raised to the same power, I can write it like this. I can write it as 3 over 8 to the x equals 7 halves. So I haven't done anything with logs. I've just simplified it enough so now I can start natural logging both sides and solve for x. So I have x natural log of 3/8 equals the natural log of 7 over 2, and I'm going to put that in parentheses, and then divide by that. So I have x equals the natural log of 7 over 2 divided by the natural log of 3 over 8. And when you put that in your calculator, you get negative 1.2772. Now, there is other ways to do that. I'm just showing you. I like it. I call it the most condensed way because the more you use algebra at the beginning, the more condensed your equation is. I will show you in class another way to do that. Okay. Here's 5. So 5, I have this equation here. I have 3 to the x equals e to the x plus 2, and I'm solving for x, and there's really no normal math, so I'm going to start natural logging both sides. When I do, I can use the rule to bring down my x, so that's x natural log of 3 equals. Now, the cool thing about this, if I natural log a base e, it basically cancels itself out because the natural log of e is 1, just so you remember that. So I have this side is just equal to x plus 2. Now, this is what I always do. This term has an x in it. This term has an x in it. This is a number, okay? I want to isolate my x's on one side. So what I'm going to do is I'm going to subtract the x. So I have x natural log of 3 minus x equals 2, okay? And then what I'm going to do is, because both these terms have an x in it, I'm going to factor the x out. So when I do, I factor the x out. I have the natural log of 3 minus 1 equals 2. Now, I'm happy about that because what it has done is isolate my x, and this is basically a number minus a number. So I'm going to divide by this glop is what I say. So my x is equal to 2 over, all right, ready? The natural log of 3 minus 1. And you got to be careful when you put that in the calculator because it's the natural log of 3 and your calculator will put parentheses around it. Then you say minus 1. You don't say the natural log of 3 minus 1 because that's a natural log of 2 and it won't come out right. So make sure when you put it in your calculator, you get 20.2814. Okay? All right, I'm working on number 6. And again, stop this whenever you want. I'm going to clear what's here so that clear ink from the page so it's not so confusing. All right, so this one here, 6, I have 10 equals 5 times, I'm going to put a multiplication there, e to the 3x. So I said, oh, I can take 10 and I can divide both sides by 5. So I end up with 2 equals e to the 3x. Now that actually comes out to be pretty simple, so I can natural log both sides because I'm solving, this is up high, I can say thanks for playing. So the natural log of 2 equals 3x. And the 3 is hooked to the x by multiplication, so going to divide by 3. So x is the natural log of 2 divided by 3. And when I put in my calculator, which you should be checking, is 0.2310. I just want you to practice doing that. Okay, let's try 7. I have 3 times e to the 3x equals 9 times. I'm putting some multiplication here just because I know it's understood, but it helps. So I decided on this one, because you could divide both sides by 3 for normal math or divide by 9. I divided both sides by 3. Okay, so when I divide both sides by 3, I get e to the x, 3x, excuse me, equals 3 times e to the 6x. Okay, and then I said, oh, wait a minute, I can actually, these bases are the same. I can divide by that. So this is what I have. I have e to the 3x divided by e to the 6x equals 3. Now this is a little bit different than the one I did before. The exponents don't match, but the bases do. So if the bases do, and I'm dividing I'm actually subtracting my exponents. This is what you end up with, e to the negative 3x, because 3x minus 6x is negative 3x equals 3. Okay, now I can natural log both sides, and this is the beauty of base e. Thanks for playing. So I have negative 3x equals the natural log of 3. Then I'm going to divide by negative 3. So I have x equals the natural log of 3 divided by negative 3. And when I put that in my calculator, I get negative 0.3662. Okay. All right, let's look at 8. I have 9 to the x plus 3 equals e to the 20x. So I look at, there's really no normal math to do. So right off the bat, I'll use a different color. I'm going to natural log both sides. Here I can say thanks for playing. So I have the natural log. I'm going to go a little bit slower on this one. The natural log of 9 to the x plus 3 equals 20x. So the right-hand side is okay, but the left-hand side, I want you to see something. If I natural log this, this exponent can actually come down in the front, but you got to remember it's a binomial. So when I write it, I'm going to write it like this: x plus 3 in parentheses times the natural log of 9 equals 20x. Okay, now I'm going to solve for x. So what I want to do is actually distribute this. All right, so I'm going to distribute the x and distribute the 3. And when I do, I get x natural log of 9 plus 3 natural log of 9 equals 20x. I'm still solving for x. This term has an x in it. This is a number. This term has an x in it. So I'm going to isolate my x's. And because this is already over here by itself, I'm going to move the x natural log of 9 on that side. So I have 3 natural log of 9 equals 20x minus x at natural log of 9. So when I do that, I'm going to factor out the x. So I have x, that's 20 minus the natural log of 9. And when I do that, look how my x is isolated. That's pretty cool. And so I'm going to, these are hooked by multiplication, so I'm going to divide by this. So I have x equals 3 natural log of 9 all over 20 minus the natural log of 9. And when I put that in my calculator, I get 0.3703. And again, I want you to practice that. So this video is the first of 2. I'm going to do one more problem here, and then I'm going to do another video for the back part of this. But this is just so you can see one way of doing it. There are more than one way to solve many of these, but I just wanted to show you one, okay? So let me clear the ink from this page, and I'm going to do number 9. So the last one I'm going to do on here, and if you want to stop it and try, go for it. But I have 8 to the x plus 7 equals 5 times, I'm going to put a multiplication there. So let's put a multiplication there. 5 times e to the 12 minus x. Okay, first of all, there's really no normal math because this 5 is really to the first power. So I'm going to natural log both sides. And when I do, I have to remember there's a multiplication going on here. So this is, I'm going to go really slow, the natural log of 8 to the x plus 7. I'm going to put it in parentheses so I don't forget to do that when I bring it down front, equals, now you got to be careful. If I natural log multiplication, I can pull it apart with addition. And then you have to natural log both of them. So that's really important that you do that. Cool things that are happening. First, this is a number on this side. This I can say thanks for playing. So that's just 12 minus x because the natural log of e is 1. Over here, I'm going to bring the x plus 7 right down. So let me extend this page a little bit so we have some room. So I have x plus 7. Natural log of 8 equals the natural log of 5 plus 12 minus x. Okay. So this right-hand side, I'm feeling pretty good about because this is a number, and this is a variable. So there's really nothing else I can do there. On this side, I'm going to distribute the parentheses, the natural log of 8. So it's going to be x natural log of 8 plus 7 natural log of 8 equals natural log of 5 plus 12 minus x. So as you can see, this term has an x in it. This is a number. This is a number. This is a number. This term has an x in it. So I'm going to put the x's on one side. So what I decided to do was, there's 2 numbers here. I'm going to bring that number over here and bring the x over here. So I have x natural log of 8 plus x equals the natural log of 5 plus 12 minus 7 natural log of 8. So if you need to stop this to see where I did that, but I kind of kept these two here, brought that over, changed the sign, moved that over to this side. When I did that, my x's are on one side of my equation. I'm going to actually factor out the x because I need to isolate it. So that's natural log of 8 plus 1 equals the natural log of 5 plus 12 minus 7 natural log of 8. And then these are hooked by multiplication, so I'm going to divide by the glop. So x equals the natural log of 5 plus 12 minus 7 natural log of 8 all over the natural log of 8 plus 1. Wow, that's a mouthful. Put that in your calculator and you should get negative 0.3074. So I'm going to stop this video now. If you need to see these again, that's fine. I don't care. I'm just going to do the back on another video so that you can check things out for there. So that's all we have here.